The width in millimeters of an animal's pupil is given by this formula, right? Where X is the illuminance of the light shining in the pupil measured in lux. So D is the millimeter, it's the width that the pupil expands, right? So we know, right, if there is like too much light, then the pupils will contract, and if there is very little light, they will dilate to let in more light. So that's pretty much what this is talking about. Okay, now it says write a limit to describe the width of the animal's pupils when the light is at its minimum. Okay? Then find the limit and interpret your results. So this is basically the limit of d of x when the light, which is x, so as x approaches 0. All right? And now let's put that in the equation. So this is the limit as x approaches 0 of 152 x to the negative 0.45 plus 85 over, you know what I'm going to do? Rather than write it like that with the negative exponents, I'm going to just write it like this. Yeah, I'm going to write it as 152 over x to the 0.45 over 4 over x to the 0.45 plus 10.
Could you possibly put them in opposite places? Like put the 152 at the bottom and the 4 at the top?
No, because you will have changed the equation then. Oh. Right? Because the equation that's given to us is like this. Oh. Okay? Now, if I were to plug in 0 here, then I get 152 over something close to 0, and then 4 over 0, and right? So that's going to be like infinitely large, right? So right? So like 152 over 0, that's going to be infinity, and this over 0 is going to be infinity, and that's not going to give me something that I can use. So I think to myself, you know what? Why don't I simplify this function? So basically, you can do that in a couple of different ways. One is do a common denominator on top, common denominator on the bottom, flip, blah, blah, blah. Or there is an easier way to do it, is look at all 4 of these terms, right? So 1, 2, 3, 4, and get the common denominator, or the LCM of all of them. That will be x to the 0.45, right? So I'm going to multiply like this, the top by x to the 0.45 and the bottom by x to the 0.45. I'm just doing algebra here, just like making it into a common denominator. And now when I distribute this, what do I get? The limit as x approaches 0, when I distribute, I get 152 plus 85 x to the 0.45 over 4 plus 10 x to the 0.45. Okay, now I'm no longer dividing by 0, right? So it's easier for me to plug in x approaches 0, right? When I evaluate this limit by direct substitution, and if I plug in x equals 0 here and here, what do I get? I just get 152 over 4, which is how much? 38 millimeters. Yeah.
Since you're multiplying by, are you multiplying by x to the positive 0.45?
Yeah, right.
So how come there isn't like a negative left over?
Because when we moved it down, it became positive.
Oh, okay.
Yeah. Okay, so that was us finding the limit, and now the question is interpret your results. So what is it that we have found? We did this and we found 38 millimeters. What is this? Can somebody explain in words, like what it is that we have found?
The width of the animal's pupil as the light is approaching its minimum.
Wait, so the reason that you plug in 0 for x is because that's like the minimum that's approaching?
Right. Okay. So the whole premise was as the light is at its minimum. So as the amount of light is approaching 0, okay? So as the illuminance decreases to 0, okay, the width of the pupil approaches 38 millimeters. Okay? Yeah, you have to write like an English coherent sentence using like a verb, a subject, proper verb subject agreement. You have to define all your pronouns. Okay? All right. Try not to use pronouns when it comes to these things. This is one of the things we train you as we prepare you for AP Calc or even, regular Calc. We try to not use pronouns. So never it goes up. No. F of x increases, right? Never it goes down. No, like the illuminance decreases, right? Okay. So write a limit to describe the width of the animal's pupils when the light is at its maximum. So now this is the limit as x approaches infinity of d of x, which is the same as the limit as x approaches infinity of that function, right? So this is the function the way it was given to us. Then we kind of like simplified the function and put it into like more usable form. So when I have to use it again, right, I've done all the work. I could just go back and take it from any step that I want. So I'm just going to take it from that last step. And I'm going to say this is equal to 152 plus 85 x to the 0.45 over 4 plus 10x to the 0.45. Now, if I want the limit as x approaches infinity, what do I take? This over that, right? Highest power over highest power. And then since they're the same exponent, then it's just 85 over 10, 8.5 millimeters. Okay? So I did it. Because it's the limit as x approaches infinity, you take the terms with the highest power on top and the bottom.
Oh, right. Okay.
And then since they're the same exponent, you reduce them.
But
So
you only do that because it's a like
as x
rational
approaches in
function, right?
correct. And well, anytime x approaches infinity, you always take the highest power. If it's a polynomial, there is just one to take. If it's a rational function, then there is two, one on top, one on the bottom. So to interpret our results here as the illuminance increases infinitely, right? So as the light gets brighter and brighter, the width of the pupil decreases to 8.5 millimeters. Okay?
Could you say approaches?
Yeah. I use approaches there, and then here I was like,
Right.
okay, we can
'Cause
also.
we, on the
Right.
coursework, are we gonna have to like write
Right.
sentences like
Mhm.
this?
Okay. Let's do another one. In molecular theory, as you see in chemistry, the root mean square speed measures the average speed of particles in a gas. Okay, so if I don't know any chemistry, can I not do this problem? No, not at all. This is what math is, right? Is you can be given a problem in any context, you have to sift through it, and you have to apply what you know to the equations as you know as you know how to use them. So, it's defined by the formula VRMS. This is the root mean squared velocity or speed, and it's equal to this: the square root 3RT over m. R is the gas constant; it's just a constant, like PV equals nRT, right? It's that R. T is the temperature. M is the molar mass of the gas particles. Okay, so find the limit of V as m approaches 0. So let's see. Limit as m approaches 0 of the square root of 3RT over m. Okay? Okay, where is m? M is here. So R is a constant, T is some temperature that the gas is at. As m approaches 0, what's going to happen to this entire fraction? Infinitely large. It's going to be infinity, right? So again, as the denominator gets bigger, the whole fraction gets smaller. As the denominator gets smaller, the fraction gets bigger, is equal to infinity / dne. Okay, interpret your answer. So as the mass of the particles approaches 0, the average speed increases infinitely. Does that make sense intuitively? Right? Infinitely. Right? Like as the mass, like as something gets lighter and lighter, it's going to be, moving faster and faster. Okay? All right. Next one. The limit of v as m approaches infinity. So the limit as m approaches infinity of 3rt in a square root over m. Again, m is here. As the denominator gets infinitely large, the whole thing is going to be 0. Okay? Equals 0. And again, what would be the sentence that we write here? Right. So as the mass of the particles increases, as the mass of the particles increases, the average speed approaches 0 or decreases to 0. Okay? And again, you can imagine as the particles get really, really heavy, they're gonna slow down, right? Okay, so moral of the story. I can't write this often enough. The limit of 1 over x as x approaches infinity is how much? 0. Okay? If you have one pizza and you're dividing it among a group that's getting bigger and bigger, everybody's going to get 0. Okay? The limit of 1 over x as x approaches 0 is infinity. Okay, you got to say this like, with your evening prayers every day.